Today we're going to do a webinar on a new mechanical workflow for MEP. I'm Bruce Johnson, your Senior MEP Technical Specialist at ATG. Been doing this for a couple of years here now, and I've been working with the MEPPP for almost 5 years on and off. And I wanted to show a way to potentially get some better productivity out of the pack, potentially, for the mechanical side. Well, it doesn't mean that this is not a useful tool for other people to watch. It is, because you should get some ideas on things you can do with schedules. So even though it applies primarily in this particular case only to mechanical, if you are electrical or plumbing or even architecture or structure, you may be able to glean some new things that maybe you could do out of this webinar. So something to think about and or watch through and apply techniques and ideas to what you do for your specific discipline in that case, if you're not a mechanical user. So my goals, how to edit schedules for your gain. Fix a broken schedule. So this should kind of be more like a header about diagnosis of the problem, fix it, discuss what the schedule is for, how can I make it better, and what does it need. Those are the things I'm going to try to get through. And the preferred outcome. How about a schedule that actually helps you not only error check, but also design a schedule that works, number one. A schedule that helps me check or error check my design for flaws based on the data available inside of Revit. Some tools to help me with the design process if possible. An easier way to enter data, time savings, and less iterations throughout the design process. So my thought here is, can this be done? Should it be done? Is there an ROI for my time? So hopefully some of that will be self-inflicted, where you'll be able to figure that out for yourselves and other people. Maybe there's still more thought needs to be happening after the fact, or think tank kinds of things in your own company. How else can we use this? Show this to more people in your company and see what their thoughts are on this as well. I did this time, let's do this thing, because I live near Nashville and lots of people here say thing instead of thing. So time to exit the PowerPoint and jump into Revit and see what we can do, how much damage we can actually get done in this case. All right, switch to the correct Revit screen, and I'm going to go to my schedules. So schedules are the things I'm pertaining to today, and if I jump into my HVAC design, this is in the Productivity Pack, design airflow in spaces. Schedule is pre-made for those who have bought the pack. Hundreds of schedules in the pack, in case you didn't know that. So if you are always struggling with building your own schedules, we've already done that for you if you want to use ours. It just costs a little bit of money. That's all it is. So here in my space airflow schedule, what I have is my room number, my room name, or space number, space name, area, volume, and actual CFM. So in the gray, it's counting for me the CFM of the devices I've already placed in that room for my air terminals. This is also doing return air grill. So if there's RG, it's return. If it's SD, it's supply diffuser. I should have some EXs in there somewhere, I think, for exhaust. See if I can find some in there real quick. Not sure if I do or don't on exhaust at the moment in my particular demo set. So usually I have all three, because I have an actual return and actual exhaust airflow fields over here as well. So the first thing I want to show in the webinar today is that in my pack, under Design Airflow in Spaces, under the Design menu for HVAC, I do have a busted parameter in here that says each of these air terminals, the 3-cone diffusers, the supply grills, all that, those should have values in there for that room if there's a number in the gray. So 400 CFM, 600 CFM, those should be filling out. Anything with the next size on it should be filled out. So there's a bust in my schedule, so I got to figure out how to manipulate that first, right? So if I go to my fields, I'm looking for what is actually in there. The fields on here are on my spaces. So the spaces have headers on them. So the ID is the number of the space, the description of the space, model, next size, airflow, name, number, area, volume, actual supply, airflow. So actual, doesn't say supply, but actual airflow is actual supply. Calculated comes from my heating and cooling loads, and that's being brought from that table. The calculated, the supply airflow check is this red line here and the difference percentage. So there's a conditional format that says compare the actual supply airflow to the calculated airflow, and then tell me what the difference is. So it's 40% deficient by percentage from what the room should be. It's 1200 now, needs to be 2010. So that's what Revit's telling me after the spaces have been applied, the ASHRAE table information has been set, the air terminals have been specified at 300 CFM each. So I get 1200 total for 4 different diffusers, and my total is looking for is 2010. So I should have like 500 in here, right, for each of those. Or I need to go in and add a few more at 300 so that I maintain my velocity or whatnot. Maybe not have an NC that's too high or something like that. So in those air terminals there, I need to be able to see what those are. But these are all my space schedule components. There's also each individual air terminal listed here, which is being done with an embedded schedule. So up here I have an embedded schedule at the end of my my parameter data and whatnot for my main schedule, my space schedule. The embedded schedule is an air terminal schedule. So I pick on embedded schedule, and now I see that there's a bunch of component information here, identity type mark, which is my SD11s and all that, my description, 3-cone diffuser, supply grill, etc., my model number. So here's a model TMS versus a 300F versus Omni AA. Those are my model numbers. Neck size, 8-inch, 6-inch, right? So just looking through my schedule, finding out what the things are. Airflow is currently blank. That's my busted parameter at the moment. What is airflow actually supposed to be in this case? If you don't know, we have to do a little interrogation of the families themselves. So if I were to go back up to a, say, working HVAC plan, floor plan, design 01, and look for a diffuser. Here's a couple of them up here. Select on that. Where is my CFM in my properties list? Here it is. Here's my CFM. The actual parameter being used is design airflow rate, not airflow. So CTC didn't get this one updated for whatever reason, so I need to go in and figure out how to get this parameter to show up in my embedded schedule. Otherwise, it's not going to show me the proper things that I really want, right? So in this case, if I go back to my embedded schedule for my properties, embedded schedule properties, and look for my airflow. Airflow is wrong. I'm removing that. And I did look for the actual parameter if I needed to screenshot that or write it down on a sheet of paper or something. In this case, looking for design airflow rate. I'm going to push that into the same space where airflow was before, and that should actually fix my schedule very quickly. So it's going to think for a moment. We get the little windows spinny. You're going to have to wait for a moment. And now I've got all my CFMs in there for all my air terminals, right? But to do layouts of air terminals and have the values as correct as possible, I notice I've got all these red fields in my conditional format. Those are all set to 5% difference in my schedule. So if I looked at formatting, looked at, which one is it? Supply airflow check. That's where the heading is set to difference percentage. If I do my conditional format, I'm going to change my background color to orange because that's a little easier on my eyes than red and black. It's currently 5% negative, 5% positive. So if it's within this 10% window, close to 0, then that will turn the field white instead of orange. So if I'm going to make that quick little change, I just want that to be easier to read those numbers because my eyes are not so good as I get older. So I did a quick change on that just to validate, yes, I've got all these things where none of my rooms are balanced with heating and cooling loads. So that's not good right now, right? So my idea here is if we have all these being placed in each room and somebody's guessing, I think that's 300. I think that's 3,000. I think this is 5. I think this is 200. I have some that are zeros. I have 300s. I have, sometimes I have 150s and stuff. Here's, I've got 300s across the board until I get to the last 3, which have 0. So those are no fun, right? I have 2100 in the room. The room only requires 981. So I'm way off and I don't have a value here that's associated the way I think it should be. So trying to figure out how can I increase my productivity. What if I had a way of showing only supply terminals, not return and exhaust, number one, so I can remove or hide these extra fields at that point because I don't really want to see those. I'm just going to do that now. I don't even know if I want pressure check, but I'll leave it in there for now. Well, let's hide those out. Actually, let's undo one time. Let's make it, come on, back to a field here somewhere. There we go. Let's do a schedules duplicate and make my own schedule instead. Something different from what I have right now. So when I build that one, it's just going to make a copy. I want to duplicate it, right? So maybe I click in here and make this a BHA Bruce schedule. And it's not really a copy, it's just my thing that I'm working on right now. So I fixed the real schedule. Now I'm going to do some tinkering in my own schedule. And I really only care about things that are in the supply side. So I'm going to hide out the pieces that I don't need in this case to make my schedule easier to read. And then I'm going to do things to it. So I'm going to go back to my embedded schedule because I'm noticing that my SDs on my identity mark are easy to find. And the RGs and all that for return girls, don't really need those. So I'm just going to make myself a filter real quick based on identity type mark. It's not parameter exists. Maybe it's equals to get me started. And then I have like an SDS something, right? Supply diffuser. And it says SD11. I don't want to filter out all the SD11s, so maybe I'd go to begins with SD. And then I should get a list when complete of only supply diffusers. All my RGs and stuff in there should just disappear when that applies. Looks like I still have some in there. Why do I still have those in there? Always when I'm trying to do something, does it say? I think type mark begins with, didn't take SD. How about that? Okay, and okay. My spinny, now all my R's are gone, right? But all my SDs remain. So all my supply diffusers are still there. So I just cleaned up my schedule to only be supply. Because what I'm really wanting to do is get my actual and my calculated to balance very easily. So to also figure out what those should be, I kind of need Revit to tell me what those values should be, right? I know based on these two numbers that these should be like 500s, right? And I may just leave them 500s, but there's a little bit more than 500. So what's the actual value that I'm looking for? So in this case, I'm going to go back to my filters on my embedded schedule. Nope, which one? Fields on this guy, my main schedule. And I'm going to add a new parameter. Usually I do it with a shared parameter, but I'm just going to use project for now. And I'm going to call this AT count. And I want that to be a number. And I don't care which group it's in, realistically. All I want is my parameter to be AT count, and it's just going to be a number. I'm also going to do a calculated value, and I'm going to call this AT average. Oops, I probably messed that one up. I need to recreate it. AT average, type number common. I think it'll let me still fill in my formula. So my formula is going to be my calculated, the thing that's coming from my heating and cooling loads, the things that Revit thinks should be my supply airflow inside that space. Saying OK to that. I'm taking that and I'm dividing it by 1 CFM. So I'm taking the CFM off of my calculated supply airflow so that I can do a function on it. So dividing by 1 CFM means it's going to be just a number, right? So CFMs cancel each other out. Divide by 1 returns a number. And then in my last piece, I'm going to say AT count parameter, the one that I just created. So if I have a number of air terminals field that's dividing into my calculated, I should get a number for each air terminal at average. So if I build that in, Turn those on. They're going to show up here, right? Come on. All right, so those are fixed. And now let's say in here, I've got 4 air terminals because I counted them very quickly, right? That's pretty easy to see there's 4 there. So it's 502.387238. That's my number. That's what Revit wants me to give as my supply airflow. If I want to buffer that up to 525 or 510 or something like that, great, but I'm going to just do 500. So 500, enter. And we should see my number here change from -40 now to -30, right? So I go back up there and say Control C, go in here, Control V, pick in my next field, wait for that to buffer down. It should be -20 at that point. This guy, Control V, next one, should go down to -10 for my difference. And Control V and just pick anywhere. You'll notice also my next size changing from 8 to a 10 because the smart families in the productivity pack are doing that automatically, knowing that they need to be a higher CFM, that the next size has to increase based on some formulas that are built into the families, right? So ideally, this is not a bad system, and I got my difference down to less than 1% difference by using that number or a number very close to it, right? So that was my end goal, to be able to have these be set as close as possible to my supply calculated airflow in Revit. If that's not the same in Train Trace or HAP or something like that, Trace 3D Plus, you could compare those values to those systems, see what you get, and if you're within 1 or 2%, I would say we're pretty accurate. If it's 10% off, 20% off, and it's always in the same direction, always plus 20%, then I'd buffer up to like 520, 525, something like that to give it the CFM that it truly needs, and then not really care about my difference. Or I'd set my difference conditional format to not 5%, but like 20% or something like that. So it changes to white when I have that opportunity to see it make the change when I'm close. The closer that number is, like the 5% either way, the faster I know that I've got to the real number or something close to it. So depending on your software for analysis and what it says, you need to figure out how much you can trust Revit versus trusting your analysis and energy modeling tools. So that's my next step to make this thing more mine-centric. And then I also want to, in cases of having lots and lots of air terminals in a space, do I really want to count all those? 1, 2, 3, 4, and guess? And say that I think I have 12. Oh, I actually had 14, whatever that was, and get the number wrong? Or do I want to really have Revit tell me what that actual number is? So ideally, I want this thing to auto count for me, but I couldn't get a way to do that in my current system without using like Dynamo or something like that to figure it out. But in my schedule itself, I do have the ability to do embedded schedule. And in here, I think I generated a sorting and grouping where I sort by identity type mark, add a footer, and tell it to do counts and totals. And when I do that, underneath each of these fields, I should get a count for each space. So here it shows me 7, here's 6, here's 12, right? So if I'm getting that count automatically now under each little grouping where my gray area is, I can use those for my AT count. So here's 7, type in 7. Here's one with 6. It's just doing math for me, right? That's all it's doing, is just telling me, oh, what are your numbers, what should they be? So here's 12 in this one, as I recall when I was looking at them. So now here are a bunch of them that I thought were supposed to be 300, and all I really need is 140. Here's a bunch that are 300, all I really need is 235. Here's a bunch of 300, all I really need is 210. So am I going to make these 210s, 240s, 140s, 150s, depending on what you think your engineering judgment tells you to do? Make those become those things, right? Fill them in. Watch your percentages go way, way, way down, whether they go under 5% and change color or not, depends on how much you buffer those out, right? But if I make that 240, that's a percentage of probably 2 to 3% difference, so that will turn white when I fill all those in. And all the next sizes should change if needed. If they stay 8s, that's fine. If they go back to 6s, it's based on the performance data in the tables that are embedded in the lookup tables inside those air terminals. So to kind of close up shop on what do I really want this for? How many times do you guys go into a working view or whatnot inside of Revit, place those air terminals and give it a value each time, where you say, well, I think these are 125s and there's 4 of them in the room. So you place one on the ceiling, face-based, and you copy it 3 more times and do a fitting of where you think those actually should go, whether it's over desks or over tables or around things or whatever it might be. Getting the placement right is part of the battle. Getting the CFM right is the next battle, right? Before you even leave the room, most people that I know as designers will give it a CFM value on what they think it should be. Doesn't matter if they've done any calcs or not. Doesn't matter if they've run heating and cooling loads or not. They'll just say, I think this space requires about this. And that's where we get numbers like I saw down here, where 300s were twice as much as potentially they should be by 140. So I come in here and make all those 150s. Again, I'm probably more than 5% at that point, probably upwards of 6 or 7%, something like that. So it's still going to be orange, but at least I used the buffer that I really wanted in that case. So what if I go in and place all those air terminals and not care about the CFM at all? What if I leave them 0? All of them are then 6-inch neck sizes, right? Until proven otherwise. And I can come into this table after the fact and go through and add my counts after I've run heating and cooling loads, so I get the calculated supply airflow. That fills out all those fields. I fill in my counts, and then I go back and I resize all my design airflow rates so that they are now the actual ones that I really want in there. How close are we to having 100% DD on our air terminals at that point? How many more changes are we going to have to make to those? Obviously, architecture is going to make changes to the volumes and the spaces and the rooms and move your walls around on you and do all that kind of stuff in your design. But if it's a really good architect and you're doing a specific type of work like healthcare and they know what size rooms they are and they have blocks or model groups to build all that out, chances are they're not going to change a lot of that. They'll change like the nurse call stations and increase number of bodies that can sit there, things like that based on the floor size. And for those types of jobs, if it was an industrial complex, that would be a little bit different where they do change stuff a lot. If it's educational, it's probably going to be very similar, a certain class size that they really like to use or whatnot. So depending on the architect and how good they are at Revit and knowing what those spaces and rooms look like, sometimes you can really trust them to do a really good job and only have to realistically do this thing once. Other ones that are just all over the place, if it's a museum, you can expect the whole thing to change all day, every day, based on owner whimsy and artsy whimsy of architects and whatnot to make those changes, right? And that's not a slam against architects, it's just the way it is. So hopefully not hurting anybody's feelings by saying that, but there's a lot of times in certain kinds of buildings where owners don't know what they want and they have to have 20 different design options that are presented to them as what's the best thing that you like about this and make a decision. And until those design options are all exhausted, chances are things are going to change. So in those cases, I can't help you with those, right? But on really good architects, they have a really good idea of their designs, their sizes, and everything else, and they're not going to continually change the buildings over and over and over again. This is a very solid workflow, in my opinion, to be able to place those items once, do heating and cooling loads, change the values once, and then draw duct. Because if I were to come in here and say this is the reverse, I had 150 in there, but they have to be 300s. They were 6-inch necks, and they're going to go up to 8-inch or 10-inch necks. If my flex duct and everything is already all connected, I may not have enough room for the fittings if I put my VAV close to the deck, and then it can't make that change. So then by doing the sizing routine or drawing a size I thought was actually correct, do the 6-inch directly from the object up to my branch line or whatnot, then I can know that if I change size, chances are there won't be enough room for the fitting and I'll get a disconnect. And then not only do I have to fix the air terminal, but I also have to reconnect it after the fact because it disconnected because it deleted the fitting. So how much more work am I adding to myself by changing, upsizing, or downsizing elements that are in my connected workflows to get it to work exactly the way it should? In the pack, we also have Titus VAVs and Titus air terminals. So I would suspect if the lookup tables built into those are accurate, then my sizing routines inside of Revit may be more accurate than ever before. And therefore, when I do connect those up to my ductwork, I could have accurate sizing pretty close to what I need all the way to the VAV in every single room very quickly. If that's not the case, it's not doing the sizing correctly. Let's just say I do connect everything after I've done my neck sizing here with the smallest physical size. Like, let's say my largest neck size is 8 inches. And a bunch of them are 6 or whatnot, but my largest is 8. So I draw everything with an 8-inch duct. So regardless across the board, I'm not worried about my 6s, I'm not worried about 8s, I'm not worried about 10s. I'm just going to draw everything with an 8. And I connect it all up. If I've done all that, then I can run my sizing routines and have it auto-size down or up to the actual size based on the connector in the true CFM. Right? So I'm actually using Revit tools to go back and resize all of my elements. And then inside the productivity pack, we do have a little area up here called analysis, where I can look at 3 things. CFM, and my demo is a little bit busted here, where I have a bunch of red stuff in here. Red is 0 CFM up to 5 CFM, and blue is everything that's normal, above 5 CFM. So friction loss, I have the same type of diagram, color-coded. If I turn on my duct legend in this case, I'll do that real quick and show that I have up to 0.08 friction loss, 0.08 to 0.16, and 0.16 or higher. If higher is red and red is bad, I could just go in and find my my size and let it resize, and then my flow is color coded again now to blue. If I change it up one more size, it probably should be green in that case. Same thing is true of velocity diagrams. If I do my duct legend and show those, let's just say that red and maroon are bad. This one duct has red and maroon and orange and blue and gray as all the colors in the spectrum basically, except for green. I just pick on that and tell it I'm going to upsize it more than 1, maybe up to a 20. What's my colors going to do to me then? If my red and my maroon are bad and I went all the way to green, then I have 1,500 or less feet per minute all the way through that duct at this point. I'm pretty pleased with that. I don't have any, maybe my gray area is my orange. If I do want to see even more of that detail, I could come in here and add some other 11, 12, 13, 14, 15 or something like that, change those values, see the colors, say okay. It's going to change my color legend on my ducts. And now I've got some all the way up to purple. So I'm still under 1,500, but I'm within 13 to 1,500 on that segment. I go down to under 1,200 on the next one, under 1,150 on the green, then right down to under 1,100 and under 600 for my gray. I can see all that visually in one step. So being able to run sizing routines across entire runs after the fact, have it upsize or downsize to the actual size it needs for the CFM and the ductwork would be a great thing to do as the next step, and then see them by color and by range that you actually want to see them, and actually physically change ones that didn't size correctly for whatever reason, weren't connected right, or whatever it might be. Finish with the analysis views to find out what's actually there or not there as you suspect it should be, and then do those final fixes. And I would say theoretically, depending on architectural changes, this is a DD set in the making. Just label everything and get it labeled on the sheets and whatnot, the construction document views in the pack, and be ready to ship that thing out. And this literally could be done, depending on size of building, a couple hours to a couple days, depending on what it is. So anything I can do to speed things up and do less iterations, that was my end goal, right, from a PowerPoint. Those are the things I want to have happen, is I want to do less work, less iterations, less changes. And I can look at my other schedules and stuff too, and look for areas where the design criteria are not being done correctly in those cases, But here I have these visual representations of views that tell me exactly what's going on, and within a range that I'm working in, trying to figure out, is there anything I still need to change in that view? So as much as I can, pre-size, run ducts one size, auto size once, check these analysis views, and I may have just solved 3 to 10 iterations from SD through 50% CD, barring any architectural changes, right? That's my end goal. So hopefully you guys just saw some stuff that made you go, what else can we do to schedules, to have analysis and information at our fingertips that is useful to a specific discipline. So whether it's HVAC or not, doesn't necessarily matter to me. I just want the concept of stop thinking of just schedules as things that we place on sheets, and that's it. Start thinking of schedules as what information can they give me? What criteria am I trying to achieve? Do I have any rules that I want to formulate? And do I have ways of making either legends or filters or something that are going to tell me exactly what's happening in my drawing based on the information I'm given inside of Revit? If that information is accurate enough, then I'm willing to base my entire design on it. Still go back and use an analysis software and validate, is that stuff true for the design that I'm working in? If it is, then great. I did a wonderful job inside of Revit. Engineers can proof check it over and over and over again and find out how close it really is. And then if we get engineers to buy in that Revit has data that actually works really, really well, then maybe we can have more trust and less iterations out to our energy modeling software. So that would be my end goal. If I did like 7 different energy models over the course of SD through 100% CD, and now I can get that down to 2 or 3 as error checking, then that would be fantastic. It saves the engineer time, spares me time doing drafting or EIT level work. If there's questions on this, obviously you guys can get with your sales reps here at ATG if you don't have one. So just calling in and finding out who is the area rep for the area of the country that you're in, and see what you can find out to ask some decent questions or get some of us techs on the phone and kind of elaborate, like, what are you guys thinking? What do you guys want to do with these tools? And are there other tools that we sell beyond the pack or whatnot? Absolutely, through the CTC software. We also have the BIM Project Suite, the BIM Manager Suite, the BIM Data Suite, the BIM Batch Suite, and the Hive Content Management System. So if there's things you're looking to do and you haven't explored all those yet, ask for a demo. That's all I can say. We can run you through the bases on everything that you have as an initiative in your company, why it's important to you, what the timeline is to be able to do that, whether it's something out of the box or whether it's a custom configuration, whether it's family builds, whatever that might be. Explore that with ATG. Find out what we can do together and how we can better utilize your time so you're not doing work over and over again that doesn't require it. Thank you for your time. Appreciate it, and let us know how we can help.
Hey there, thanks for tuning in. If you like this video, make sure to subscribe and check out some of the other content on our channel.